Hi guys, and welcome back. We are on to the second lesson in Unit 15, which is lesson 99. And today we're going to talk about problems that involve arc length in a very specific situation. So today's date is April the 30th, and 2020. And here goes. An arc of a circle has a measure which depends on the central angle that is formed by a length which is a fraction of the circumference and the radius of that circle. That's our official statement here. If you would like it to be a little easier to digest, here's what's going on. This central angle, any central angle drawn to a circle, the radius that is creating, so we have two radii that are creating that central angle, and the arc that are being cut off by it, this intercepted arc out here, they all have a very specific relationship to one another. As long as the angle, theta, is measured in radians, that's really, really important. It has to be in radians. If it isn't in radians, we're going to put it in radians first. Then this relationship will always hold true. The length of this arc out here, arc S, will be equal to the product of the angle measure in radians times the radius. So you'll hear me refer to this as the SOR formula. It's not really SOR, but kind of look like SOR. So this is the SOR formula. The length of any arc of a circle created by a central angle will be equal to the measure of the angle in radians times the radius. So when we have a problem that involves those three things, the arc, the central angle, and the radius, then we're allowed to use this formula. So to take a look at how this might get used, here's a story. A wedge-shaped piece is cut from a circular pizza. The radius of the pizza is 6 inches. The rounded edge of the crust of the piece measures 4.2 inches. To the nearest tenth, they would like you to find the angle of the pointed end of the piece of pizza in radians. So if you think of this as being part of your circle, right, this is your central angle, then what do you have going on here? Well, they told us that the radius of the pizza is 6 inches, so radius is equal to 6, and the arc, that curved edge of the crust around the outside of the pizza, that's 4.2 inches. So using our new formula, since they're asking us for the measure of this angle over here, S is equal to theta times R. So 4.2 is equal to theta times 6, which means we have to divide by 6. So theta will be what I get if I simply do 4.2 divided by 6. And when you do that, you should get 0.7. And that's your answer. That's the whole thing. Every one of these problems is just either dividing or multiplying. And sometimes we have to change from degrees to radians first, which we're about to see here in problem number 2. So here's the deal. Find the length of the crust of a piece of apple pie to the nearest hundredth of an inch if the radius of the pie is 4.75 inches and the central angle is 30 radians. So here's my piece of pie. This is like that triangular shape piece out of the round circle that would be the full pie. They tell us that the radius is 4.75 inches, and they tell us that they want us to find the length of the crust, so that would be S. I don't know what that is. That's what I'm trying to find. They do tell me that the central angle is equal to 30 degrees. Now the problem, of course, is that I can't use this formula with degrees. It only works with radians. So the first thing that I have to do is take that 30 degrees and, like we learned yesterday, turn that into radians. So that would be 30 times pi over 180. So that would be 30 pi over 180, which of course would reduce down to pi over 6. So once it's reduced down to pi over 6, now I'm allowed to go use the SOR formula, S equals theta times R. S is what I'm trying to figure out. What am I multiplying here? Pi over 6, that's my angle, times the radius, which was 4.75. Now, as far as putting that in the calculator, I realize some of you might like to see that, so I'm going to show you. Here comes my calculator again, like what I did yesterday. What I'm going to do there is I'm going to put in pi over 6. Now you have a choice. I'm going to use that trick from yesterday again, that alpha y equals, that lets you pick choice 1 and put in a fraction. I can put this in as pi over 6, and then I can multiply it by, what was I multiplying it by? 4.75. And then all I have to do is round off. So it looks like that answer there is coming out to 2.48 something. So I want to do this one. They tell me to the nearest hundredth of an inch. So if I have 2.4870, etc., tenths, hundredths is this place here. So looking at the 7 that comes after, I must have to round up. This would be 2.49 inches. And that's my final answer. Now, just in case you don't really like using that fraction option, the other thing that you could do is in parentheses, you could just do pi divided by 6. Do it like that. It's the same thing. And multiply that by 4.75, and you get to exactly the same answer. Okay? All right. So those are the first two problems, and that's really the gist of what we're doing here. I'm just going to go through a few more sample problems for you. These are very straightforward, as long as you realize that what you're talking about is that central angle in a circle. So this problem here tells us about the pendulum of a clock swinging through an angle of 2.5 radians as its tip travels through an arc of 50 centimeters. Find the length of the pendulum in centimeters. So in case you're not familiar with the vocabulary, the pendulum, of course, is this thing. It's the thing that's hanging down that goes tick-tock, back and forth on an old clock, like a grandfather clock. If I kind of simplify what's happening here, this pendulum is swinging back and forth. So if it's swinging back and forth, we end up with that kind of pie-shaped piece, like what we used on the last two problems. This angle in here is the angle they're talking about. It says it swings through an angle of 2.5 radians. And they tell us that the arc that it's traveling, so this arc down here, is 50 centimeters, and they would like to know how long the pendulum is. Well, in this scenario, this part of this picture, if I brought it over here and looked at it like this, you should be able to see that if I drew the whole thing in, I'd be looking at a circle here. So the pendulum, the thing that they're asking me for, is actually the radius. So again, I'm back to this same situation again where I can use the SOHR formula. So SOHR, of course, S equals theta times R. S is 50, theta is the 2.5 that they told me in the problem, and the radius is the length of the pendulum. That's what I'm looking for. So now that I'm up to this point in the problem, how do you finish a problem like this? I'm solving for R. I would have to divide by 2.5. So all you have to do there is take 50 and divide by 2.5, and you should end up with 20. And it would be in centimeters because the rest of the problem was in centimeters. Okay? All right, going on to number 4. A sprinkler system is set up to water the sector shown in the accompanying diagram. Remember those old school sprinklers that kind of go and they go back and forth like this? So it's watering what's actually part of a circle. They tell me here that angle ABC measures 1 radian. So angle ABC is this angle in here. It measures 1. And they would like to know what the length of the arc would be. Well, S is equal to theta times R. So in this case, S would equal, this is so easy it seems like it's wrong, 1 times 20. And that is actually 20 feet. This was a Regents questions, guys. It was actually on the Regents exam. It's so easy, I think people were afraid they were getting it wrong, but that's all you have to do. And then you're up to the last problem. So one more problem like that. In this case, they tell us in the diagram below, the circle shown has a radius of 10, and angle B is intercepting an arc with a length of 2 pi. They would like to know the measure of angle B in radians. Well, again, I'm looking at the same piece of pizza. If your problem looks like that, if the things that they are describing involve a central angle, a radius, and an arc, if it involves those 3 things, then you know that you can use that formula from today. So here it is, S equals theta times R. In this case, that would be 2 pi equals theta times 10. And all I have to do is divide by 10. So again, if you're not comfortable doing this in your head, you can certainly bring in your handy dandy calculator, but really all we're doing here is 2 pi over 10. Now, they're not telling me to round off here, so I'm not actually putting in the 2 pi. I have to reduce the 2 over 10 part. So you can do it the long way like that, or we can use that little hidden fraction thing again and put in the 2 over 10 this way. And we end up with 1/5 either way. We get the same answer both times. And so my final answer here is 1/5 pi, or the way I would probably write it would be pi over 5. But technically they're both right. And ladies and gentlemen, that's the whole lesson for today. Nice, quick little problems, hopefully not too confusing. And there's a few questions on the homework sheet for you to practice it. Have a great day. See you soon. Bye-bye.